has a mass of 2400 kilogram. Determine the amount of tension in each cable for equilibrium. Because the mass of the slab is given in metric system, you need to convert it to Newton or kilo Newton by multiplying it to 9.81. So I do it very quickly in the beginning, and if you multiply it, it's going to be 23.54 kilo Newton. So I rounded it, and this force is going to act in the middle of the slab. This is the force that comes from the weight of the slab. So 23.54. We are looking to find these three unknowns, TC, TB, TA. In order to solve a problem like this, you're going to use equations of equilibrium and mostly moments. Moment about axis or about a point is going to be our winning equation. So by looking at this slab, you can see that if I take moment about x-axis, then TA and TB, they don't have any moment about x-axis because they are acting on x-axis. The only force, unknown force that has moment is TC. Therefore, I can find TC immediately from there. That being said, you have to look at the given forces and the configuration of the given forces and see by taking moment about any point or any axis, you can eliminate some of the unknown forces and find one unknown forces from there. So I start with taking moment about x-axis, and I assume that counterclockwise is positive direction. It's up to you. You can decide whether, or you can assume whether clockwise is positive or counterclockwise. It doesn't matter. Now, the forces that I have is TC, and the distance from x-axis for TC is 2.5 meters. So TC times 2.5. This is 2.5, the distance from TC to x-axis. And it's acting in the positive direction. Then I have two known forces. One is 15 kilonewton and one is 23.54. And they are going to act in the opposite direction. Therefore, they are negative. So 15 kilonewton times the distance is half meter. You can see on the slab the distance is half meter, and the second force that I have here is 23.54 that I calculated. That's the weight of the slab, and because it's acting in the middle of the slab, the distance is 2.5 divided to 2 is 1.25 meter, and that's equal to 0. Don't forget TA and TB, they don't have any moment because their arm or their D distance is 0. Their moment is 0. So from here you can find clearly TC, which is going to be equal to 1 over 2.5 times 15 times half is going to be 7.5, and because I'm moving it the opposite of the other side of equal, it's become positive. Again, this become positive, and it's equal to 29.43. If you solve this, this is going to be equal to 14.8 kilo Newton. I calculated one of the unknowns by taking moment about x-axis. I'm repeating, you should start with taking moment about a point or an axis that eliminates some of the unknown forces, and I started with taking moment about x, and that eliminated TA and TB. Now I'm going to take moment about y-axis, and by doing so, clearly I'm going to eliminate TA. I already calculated TC. That means that I can calculate TB from there. So the second equation that I'm going to use is sigma m about y-axis. I'm assuming again this is my positive direction. I follow the same. So is 0 again by writing. So I have TC. So you can see that TC is going to fly in this direction about y-axis, and I assume that this is my positive direction. Therefore, TC is going to have a negative moment. The magnitude of TC is 14.8, so negative 14.8 times the distance is 1 meter, 1 meter, and 2 meter. Total is 4 meter. Don't forget, I'm taking moment about y-axis, and it's flying. It's like assume that it's flying. It's rotating about y-axis. In which direction? In this direction. It's the opposite of the direction that I assumed is positive. But 15 and 23 are going to act in the positive direction because they're going to see they're going to fly in this direction, which is the positive direction that I assume. So it's going to be plus 15 kilonewton times the distance is 3 meter plus 23 29 23 sorry 23.54 kilonewton times the distance is 2 meter. It's in the middle of the slab, and that's going to be 0. Again, TA doesn't have any moment because TA is on y axis itself. And from here, oh, I forgot to write TB, sorry. So you should write TB also. TB is going to act in the opposite direction again. So minus TB times 2 meter is 0. From here you can calculate TB, which is going to be 1 over 2 times negative 59.2 plus 45 plus 47.1, and that's going to be equal to 16.45 kilonewton. I calculated the second force. Then now I have, out of 3 unknown forces that were TA, TB, and TC, I have 2 of them now. Now I have just one unknown. I can write sigma F Z is 0 this time, and I can find the third unknown, which is TA. So TA plus 14.8, which is TC that I calculated, plus 16.45, which is TB that I calculated, minus 15 kilonewton, which was given, minus 23.54, which was again given. The weight of the slab is 0. From here, TA is equal to 7.29 kilonewton. So I calculated and I solved all 3 unknowns.